Alright, let's dive into a fundamental question that often crosses the minds of budding scientists and seasoned researchers alike. Why do we even bother with science experiments? What's the real point of all the beakers, test tubes, and late nights in the lab? I mean, isn't it enough to simply read about groundbreaking discoveries in textbooks, diligently memorize the established facts, and then just move on to the next chapter? Can't we just take the word of the experts and call it a day? But if you're anything like me, you've probably realized there's something undeniably electric, something truly captivating, about actually getting your hands dirty and doing an experiment yourself. It's a different kind of learning, a more profound experience. Think back to the very first time you carefully mixed two seemingly innocuous chemicals together in a lab setting, or maybe you eagerly dropped a handful of Mentos into a bottle of soda, anticipating the geyser that was about to erupt. The result wasn't just a colorful mess on the table that you had to clean up, it was tangible proof, right there in front of your very eyes, that what you diligently read about in textbooks actually happens in the real world. It was a validation of scientific principles. And that's the real underlying purpose of science experiments, transforming abstract specimens and complex theories into real, tangible knowledge that you can see, touch, and understand on a deeper level. Sure, lectures and presentations can effectively explain complex concepts and theories, but experiments let you truly them. You're not just passively absorbing information, you're actively engaging with it. It's one thing to simply hear about Newton's laws of motion in a classroom. It's an entirely different experience to actually roll a ball down a ramp and witness inertia and acceleration in action, observing the principles firsthand. Experiments are so much more than just checkboxes on your syllabus or requirements for a grade. They represent a deeper dive into the unknown. They're fundamentally about curiosity, asking that crucial question, what if? And then embarking on a journey to find out the answer for yourself through careful observation and meticulous experimentation. It's in the iterative process of trial and error, the often unpredictable and sometimes startling unexpected results, and even the inevitable failed attempts, that the most profound and lasting learning truly happens. Of course, sometimes things go exactly as planned and the experiment yields the predicted results. But honestly, it's often the unexpected surprises that truly stick with you, challenging your assumptions and making you question what you thought you already knew. Let me tell you a quick story from my own experience. Back in my freshman year of college, I had the opportunity to help run a seemingly simple experiment focused on plant growth. Just the basics: light, water, and seeds. But about halfway through the experiment, one particular group's plants started inexplicably dying. Instead of simply dismissing it as a failure or an anomaly, the group decided to dig deeper and investigate the cause. Through careful analysis, they discovered a subtle chemical residue that had been inadvertently left on their pots from a cleaning agent used previously. That seemingly insignificant mistake turned into a valuable real-world lesson about the critical importance of contamination prevention, and the absolute necessity of having proper controls in any well-designed experiment. And that's the true magic of science experiments. They teach you not just what to think, but more importantly, how to think critically and analytically. You learn to formulate better, more insightful questions, to approach information with a healthy dose of skepticism, and to ultimately trust empirical evidence over preconceived assumptions or biases. In essence, experiments serve as the crucial bridge connecting the abstract world of learning about the world and the concrete reality of actually understanding it on a fundamental level. So, the next time you find yourself meticulously setting up a beaker, carefully measuring drops with a pipette, or diligently scribbling observations in your lab notebook, remember, you're not just mindlessly following instructions. You're actively building knowledge from the ground up, using your own hands, your own mind, and your own critical thinking skills. That's what the essence of science is all about, moving from examining specimens to constructing knowledge, from grappling with complex questions to uncovering meaningful answers, and ultimately, from initial confusion to a state of profound clarity and understanding. And the best part is, you get to be an active and integral part of that incredible journey of discovery. Thanks for tuning in and exploring the purpose of science experiments with me. Stay relentlessly curious, never stop asking questions, and above all, keep experimenting.